In question number 18, in a standard YDSC setup, slit width D is equal to 4 mm and capital D is the distance of screen from the slit. A point source S is placed symmetrically with respect to two slits and at a distance of D by 2 from the slits as shown in figure. Now if source S starts oscillating in SHM parallel to the slit width with an amplitude 1 mm, then what is the amplitude of oscillation of central maxima on the screen? And we have to give the answer in millimeter. Suppose the source is moved to this position and its amplitude is 1 mm. So at that moment, if I see, let the central maxima has moved to this position, and if the amplitude of the central maxima from this position will be x, then I can say that the waves are reaching in this direction and they superimpose at this point. So suppose this is S1 slit and this slit is S2 and this point is P. So the path difference must be 0 if this is the point of central maxima. So I can say that SS2 plus S2P minus SS1 plus S1P must be equal to 0. Further I can write S2P minus S1P minus of SS1 minus SS2 must be equal to 0. I have written in S2P and S1P in this term, and SS2 and SS1 I have written in this way. We know that if this separation is X, this is D, this is capital D, then this part difference S2P minus S1P can be written as X D by capital D, which is a standard form, minus. Now SS1 I can write in this way. SS1 is equal to under root of D by 2 whole square, because this separation is D by 2. So this separation in terms of small d, because this separation is 4 mm and this separation is 1 mm, can be written as 3D by 4, and this separation can be written as 3D by 4, and the remaining separation can be written as D by 4. So I can write SS1 as D by 2 ka whole square plus 3D by 4 whole square. Similarly, SS2 I can write under root of D by 2 whole square plus D by 4 whole square. So if I solve this SS1 minus SS2 by applying the binomial theorem, then I can find its value comes out to be D square by 2 times capital D. So from here we get the value of X, which comes out to be D by 2. The value of D in question is 4 mm. So 4 mm by 2, so it comes out to be 2 mm. So the correct answer for question number 18 is 2. Let's move to question number 19. In question number 19, a thin plane non-conducting disk of radius 2 meter having uniform surface charge density sigma is equal to 1 by pi on both faces rotates about an fixed axis through its center and perpendicular to the plane of disk. Angular velocity of rotation omega is equal to 1 radian per second, and there exists a unidirectional uniform magnetic field B is equal to 1 Tesla minus J cap in the plane of disk. Calculate the value of torque in Newton meter the disk would experience. So we know that this is a charged disk and this charge is rotating in the magnetic field. So first of all, find out what is the magnetic moment of this charged disk. So in order to calculate the magnetic moment of this charged disk, I am considering a circular element of radius r of thickness dr. So the charge on this element dq can be written as sigma into 2 pi r into dr. Since charge lies on the both faces, so multiply by 2. So it is equal to 4 pi into sigma into r dr. So the current due to this motion of charge can be written as I is equal to dq into omega by 2 pi. So if I substitute the value of dq and solve this, it comes out to be 2 omega sigma into r dr. So this is the current in this considered element. If I write the magnetic moment of this considered element, so that can be written as dm is equal to pi r square into I, that is 2 omega sigma into r dr. So if I solve this further, it can be written as 2 pi omega sigma into r cube dr. So if I write the torque, because the magnetic moment is perpendicular to the magnetic field, so the magnitude of torque is dm into b. So d tau can be written as dm into the value of the uniform magnetic field, that is b. Since the torque due to different element are in same sense, so the net torque experienced by the disk can be written as integration of d tau, and the variable is small r, that varies from 0 to capital R. So if I solve this, it comes out to be pi omega sigma b r की power 4 by 2. So if I substitute the data, then the value of this torque comes out to be 8 Newton meter. So the correct answer for question number 19 is 8. Let's move to question number 20. In question number 20, in a series LRAC circuit, initially the power factor at angular frequency omega 1 is √3 by 2. If angular frequency is changed to omega 2 so that power factor becomes 1 by 2, then find the ratio of omega 2 by omega 1. So we know that in case of series LR circuit, tan phi is given by XL by R, that is equal to omega L by R. Now, in the first case, when the angular frequency is omega 1, power factor is √3 by 2. Means the value of phi is 30 degree. So I can say that 1 by √3 is equal to omega 1 L by R. In the second case, when the power factor becomes 1 by 2, it means the value of phi becomes 60 degree. So I can write √3 is equal to omega 2 L by R. So if I take the ratio, then omega 2 by omega 1 comes out to be 3. So the correct answer for question number 20 is 3. By this, I wish you all the best for your preparation. Have a good luck. Thank you.